Okay, we are on number 11 of Chapter 5 and Chapter 5 and Chapter 6 examination review. And number 11 says, which elements donate electrons to form cations and which accept electrons to form anions? Just remember that the elements on the left-hand side of the periodic table, they're going to donate electrons. They're going to try to be like the noble gas that is preceding them. And so by removing one electron, by releasing one electron, in this case, every element in this column right here is going to, or every atom is going to try to release one atom, or electron, to try to be like the preceding noble gas. So these are the atoms on the left side of the periodic table that are going to tend to become cations, positively charged ions. On the right-hand side, we're going to have the anions, not of course the noble gases, but everything else on this side of the periodic table is going to have a tendency to gain electrons. The halogens, for example, are going to want to gain one electron. These are going to want to gain two electrons, and so on. So, cations on this side, once again, cations on this side, anions on this side. All right. Number 12 says, which family or group requires the least energy to remove an electron and which requires the most? Well, let's talk about which requires the least to remove electrons. First of all, the alkaline metals, these metals right here, they want to have an electron removed. They want to be like the first noble gas, so it's not going to require much energy at all to remove an electron from here. On the other hand, the noble gases over here have a stable octet of electrons in their outer shell. They're going to require a large amount of energy, a large number of kilojoules per mole to remove electrons from these atoms here. So once again, the alkali metals are going to require a lot of energy to remove electrons, or an electron, and the noble gases are going to require, let's go back. The alkali metals are not going to require very much energy to remove an electron. The noble gases will require a great deal of energy to remove that electron. Number 13 says you should know that elements in the same family or group have similar chemical and physical properties. What elements might have similar chemical and physical properties with lithium? Let's move over here to the periodic table. So once again, everything in the first column is going to behave the same. They're going to have the same physical and chemical properties. This is lithium here, so sodium, potassium, rubidium. All these are going to have the similar chemical and physical characteristics. They tend to be very reactive with water. In fact, as you move down the periodic table, if you go down the periodic table from lithium to sodium, potassium, and so forth, you'll see increasing reactivities. They tend to react more vigorously with water as you move down, but still they're very, very reactive. In the second column of the periodic table, the alkaline earth metals are not quite as reactive, but still they have similar physical and chemical characteristics. So everywhere you see a column, everywhere you see a family or a group, they're going to have similar physical and chemical characteristics. All right, that is number. That's number 13. Let's go to number 14. You should be able to compare the melting and boiling points of metals, ionic compounds, and covalent compounds. Start moving into the new material now. Remember, metals have very, very high melting points and boiling points. Metallic bonds are very, very strong. In order to break those bonds, it's going to require a lot of energy. So metals then have very, very high melting and boiling points in the thousands of degrees, in order to melt a metal. Ionic compounds, for example, sodium chloride is an ionic compound. Those are going to require a lot of energy, but not nearly as much as metals. So metals will require a temperature in the thousands of degrees. Ionic compounds in the hundreds of degrees, and then covalent compounds will require the least energy of those three. So the order again is from high to low. Metals require the most to melt and boil. Ionic compounds, less than that, but the lowest is the covalent compounds, because the bonds between covalent compounds is not very strong, relatively speaking. And finally, number 15. Number 15, we said you should be able to determine whether a bond formed between two atoms is most likely to be ionic or covalent or metallic. Remember that two atoms that are on the same side of the periodic table, they will tend to, on the same side of the periodic table, will tend to be metallic. So metallic bonds are formed by atoms on the left-hand side of the periodic table. If you want to do ionic bonds, you're going to take atoms that are on the left side of the periodic table, like sodium or magnesium or calcium or potassium, and you're going to combine them with atoms on the right side of the periodic table. So a metal with a non-metal is going to form an ionic compound, and covalent compounds are going to be formed when atoms that have similar electronegativities are such as you would encounter on the left side. So if you had two atoms that were on the left side of the periodic table, like maybe oxygen and carbon, those are going to form covalent bonds because the electronegativity difference is not very great, certainly not above 1.7. And that takes us through number 15, and so our next video will take us through number 20. Thank you.